Hi, Doug McKown here. Today I want to talk about pulley systems and mechanical advantage. I want to see how easy it is to set up a pulley system, how simple it is to figure out mechanical advantage, and how easy it is to make these things work for us and make work easier. So let's get started. So, what do we need to make a pulley system? Well, we need a piece of rope. We need a pulley. This is just a standard rescue pulley. These are the things I'll be using to set up our systems. And we need a job to do. So what we're going to be doing is lifting this weight and trying to make pulley systems to make the work easier. So that's what we're going to do. Let's see how we can start to hook this up. Alright, so the first thing I did was I tied my rope directly to the load, to this weight. So if I want to lift this, and the weight weighs 10 kilograms, then I have to lift 10 kilograms of weight. That's a one-to-one system, no advantage. That's what we're trying to improve. So the first thing I'm going to do is put one pulley into this system. Let's see what that looks like. So I started by putting the pulley up here at an anchor point, and I still have my rope tied to the load. So now I lower the rope up and down, the weight goes up and down. This pulley has nothing to do with mechanical advantage. All it's doing is changing my direction of pull. It's exactly the same as me trying to lift the weight up and down. It just means that I can now pull from different angles and raise the weight. But it has nothing to do with mechanical advantage. This pulley sits still, it doesn't move as the system moves, so it's called a fixed or static pulley. All it does is a change of direction. There can be lots of these in a pulley system. They just let me send the rope back down here and make it easier for me to change my direction of pull. So that's all this pulley does. Now I'm going to change the system a little bit and put in a pulley down here at the load. So this is what this looks like. So what I've done here is I've just changed my anchor point. I've undone my rope from the load and I've secured it up here to a nice strong anchor point. Great big tree or something. I've run my rope down to my load through a pulley, and now it's just going back up to another change of direction pulley. Again, no mechanical advantage up here. As we talked about before, this is a static or fixed pulley. No matter what happens within the movements of the system, this pulley just stays still. This pulley, however, is a little bit different. This pulley goes down and up with the load. It moves the same speed as the load, and it goes the same direction. So this is called a traveling pulley, because it travels the same way the load does. And this traveling pulley is what creates mechanical advantage. Now, the way we measure mechanical advantage is we measure how much rope you have to pull in to raise the load a given amount. So you can see that if I want to raise this load, this pulley point, by 20 centimeters, I have to pull in this 20 centimeters of rope, and I have to pull in this 20 centimeters of rope. So I pull in 40, the pulley goes up 20, so 40 to 20 is 2 to 1. So I have to pull twice as far as the distance that I want the load to go up. So this is how we're creating mechanical advantage. Now let's just put some marks on here and see if we can measure this out and how it fits in to making it easier to lift the load. Here we go. Okay, so I've made some marks on here so we can see what really happens. So if I set my load so that it's 0 right at the center of the pulley, I want to move that up 20 centimeters, I'll mark my rope over here and see how much we have to pull in. So I pull it in to 40 centimeters, and it's gone up 20. And that is what makes mechanical advantage. A traveling pulley adds 2 to 1 mechanical advantages anywhere that it shows up in the system. Because they move with the load, it makes it easier to lift. So if this load weighs 10 kilograms, what I'm doing is I'm pulling 5 kilograms, but I'm pulling twice as far. So now, it only takes 50% the amount of work to raise this load. So I pull twice the distance with half the force. And that's how traveling pulleys make life easier. And that's all you need to know about mechanical advantage. The fact that every traveling pulley gives you a 2-to-1 mechanical advantage. So let's see how we can make that work for us even better. Now, what I'm going to do next is just add more pulleys, because that's all you do in a pulley system, is you add more pulleys. And every traveling pulley that you add is another 2-to-1 mechanical advantage. And that's how you create mechanical advantage. That's how you make a very powerful pulling system. So let's see what that looks like. Okay, so what I've done here is I've just added another traveling pulley to my load. So I've come through the static pulley, through another traveling pulley, and up through another static pulley. Now remember, these pulleys have nothing to do with mechanical advantage. They're just redirecting the rope through the system. This, however, is a second traveling pulley. Just like the first one, it goes up and down with the load. And what that means is that this pulley is a 2-to-1 mechanical advantage, as we measured out before. Another traveling pulley is another 2-to-1 mechanical advantage. Because to raise this load by 20 centimeters, I have to pull in this 20 centimeters, this 20 centimeters, this 20 centimeters, and this 20 centimeters. And that is 80 centimeters. That is 80 for 20, which is a 4-to-1 mechanical advantage. So now, when I raise this load 20 centimeters, I have to pull in 80 centimeters of rope. So when I do that, I'm pulling 4 times as much rope as the load goes up. Which means if this load weighs 10 kilograms, I only have to pull with 2.5 kilograms of force to raise a 10 kilogram load. So that's a 4-to-1 mechanical advantage. But it's as simple as that. 1 traveling pulley is 2-to-1, 2 traveling pulleys is 4-to-1. And that means, of course, that we could just keep adding traveling pulleys. If I put another traveling pulley in, that would be 2-to-1, 4-to-1, 6-to-1. If I put another traveling pulley in, it would be 8-to-1. So traveling pulleys just magnify your mechanical advantage every time you put one in. So, let's look at this. We have 2, 4-to-1, 6-to-1, 8-to-1. The question is, how do we get 3-to-1, 5-to-1, or 7-to-1 mechanical advantage? Well, let's have a look and see what that looks like. So, what I've done now is I've undone my anchor rope from up here, and I backed and tied it directly to the load. So this is the end of my rope. This is the rope that I've taken out and tied onto my canoe or my car or my tree stump, or whatever it is I want to move. I go back up to a nice solid anchor, through a static pulley, back down to my load, to a traveling pulley, where of course the mechanical advantage comes from. Then I've just gone to another change of direction pulley so we can run the system here. This pulley has nothing to do with mechanical advantage. So what mechanical advantage do we have here? Well, we've got a 2-to-1 mechanical advantage from this traveling pulley. So we know the system's at least 2-to-1. But the anchor rope, when you tie it on the load, it moves with the load. The load goes up and down, the main rope goes up and down. That means it has to factor in to the mechanical advantage. And it works sort of like half of a traveling pulley. So for pulling this system in, I have to pull in 20 centimeters from here, plus 20 from here, plus 20 from here. So I pull in 60, the load goes up 20. That is a 3-to-1 mechanical advantage. One from this rope, one from this rope, and one from this rope. So this is basically the standard 3-to-1 mechanical advantage that everybody uses in their day-to-day pulley needs. It's the go-to system that you'd hook up for anything at all. Tying your boat in the car, pulling guide ropes tight, pulling a tree stump out, whatever you need to do, the 3-to-1 system is the go-to. And what you do, you tie your rope to the load. You always start there. Whatever you're trying to pull, you tie on the rope. You come back to a nice solid anchor, you put in a directional pulley, go back out to the load, and you put in a traveling pulley. That's your 3-to-1 system. This one, remember, isn't doing anything. You can pull directly on here. It's the same 3-to-1 system doing that as it is doing this. Okay? So 3-to-1, because of a traveling pulley, you have 2-to-1, and the main rope is the 1-to-1. So just like when we were doing the 2-4-6 pulley system, if I put another traveling pulley in here, that would be another 2-to-1 mechanical advantage. So I would have 1-to-1, 3-to-1, 5-to-1, another one would be 7-to-1, and so on. That's how pulley systems work. It's very, very simple. So, as a review, traveling pulleys make mechanical advantage. Any traveling pulley attached to your load gives you a 2-to-1 mechanical advantage. With this and the main rope tied to the load, we have a 3-to-1 mechanical advantage. As you add more traveling pulleys, you add more mechanical advantage. And that's all there is to pulley systems. Static pulleys, traveling pulleys, you get mechanical advantage, and it makes life easier to lift and pull and do real work. So there you go. That is pulley systems and mechanical advantage. If you like that, press on the little subscribe button. If there were things that weren't in here or things that were confusing, please send me a comment, because that'll help me straighten these things out for the future.